All right, so we were working in section 1.3 last time, and I believe that we are on the information that's right after example 2. Does that look right to you guys? Yeah? Okay. So some things that we had encountered last time is this idea of doing trig functions of any angle. We established what r is, and it's the Pythagorean theorem at play, right? So it's the square root of x squared plus y squared. And then we defined sine, cosine, tangent, and their reciprocals based on that. And then we had done a couple of examples based on giving an angle measurement. That was, well, that's this one. We were given an angle measurement, and this one where we were given an ordered pair in space, and we can do it both directions. So as we take a look at those 6 trig functions, we're going to take a look at a grid and just talk about what happens and where we get values for each of them that are positive and or negative, okay, whichever one it is. So in quadrant 1, x values, remember quadrant 1's over here, x values and y values are both positive, right? So in this quadrant, everything is positive. What that means is that all of our trig values, okay, it's not working. All of our trig values are positive. I'm going to just write greater than 0. Sine's greater than 0, cosecant's greater than 0, tangent's greater than 0. They're all positive in quadrant 1 because x and y are positive. Okay? Over here in quadrant 2, which values are negative? X or y? X values are negative, right? So over here, just as a reminder, x is negative. So if you take a look back at the front page, where we defined what tangent and cotangent and secant and cosecant and sine and cosine all are, the ones that involve x are now going to be negative. So which ones are negative in this quadrant?
Tangent and cosine.
Tangent and cosine and their reciprocals, right? Okay, so it will be easier for us to define which ones are positive and write that down. So which ones are positive? Sine and cosecant. So over here, the sine values are positive and the cosecant values are positive. Those go together. They're going to match up. So if you don't want to write them both down, feel free. All right, down here in quadrant 3, yeah, so here I've got positive values for only tangent because down here in this quadrant, x is negative and y is negative, right? So if it's got an x in it, it's going to be negative. If it's got a y in it, it's going to be negative. And if it's got both x and y, which is tangent, negative divided by negative is a positive. So down in this quadrant, the tangent values are positive. And because they go together, so would cotangent, because it's going to be x over y. And then in our last quadrant over here, now my x values are positive, but my y values are negative. So anything that has a y in it's going to be negative, which is going to include tangent, right? And it's going to include sine. So in quadrant 4, the cosine values are positive because they involve x only. And because they're connected, whoops, that should say secant, the secant values are also positive. All right, you want a mnemonic device? I like mnemonic devices. Oh, you've got one. Okay, so here's the one that I use. Okay, so they're not the co-functions. They're sine, cosine, and tangent. So S is sine, T is tangent, C is cosine. Everybody see where those are coming from? So this S right here is matching up with sine, T is tangent, and the C is cosine, okay? So you can remember the letters, just write that's an ASTC, that's fine. Here's the one that we're going to propose. It's a smart trig class. Yeah, isn't it? Yeah, you guys are. This is a smart trig class. It's a mnemonic device. What did you say, Isaiah?
All students take calculus.
All students take calculus, which is an unfortunate scenario that's not true. But you guys are all in here because you're headed in that direction for the most part. So use whichever acronym you would like, but it's the one way to remember which values. And remember, these are the values that are positive. So everything else is negative in these quadrants. So using that information, we're going to do an example where they simply give us a couple of pieces. They tell us that the sine value is negative and the cosine value is positive. Okay? So I'm going to do this sort of by process of elimination with a graph. You can probably look at it and see for some of you, and some of you are like, I can't do two pieces at the same time. I'm not seeing it. If your sine value is negative, where is sine negative in terms of the 4 quadrants?
3 and 4.
3 and 4. So sine values negative means that I'm down here. Okay, that's what it means. And then between these two, which of these two have cosine values that are positive? Now, let me mark it. It's in quadrant 4. Yeah. So the cosine values of these two are right here. The other way that you could do this is you could say, okay, where are my cosine values positive? Well, it's 1 and 4. And you could say, where's the overlap? They overlap in quadrant 4, right? 1 and 4 is where cosine is positive. So my answer is that it's in quadrant 4. That's where this piece of information coincide. Okay, so using that now, we're going to think about how we can kind of combine a couple of the things we've been doing in this section together. This tells us we're going to find the value of the remaining trig functions of theta, which we've done. But now specifically we're told which quadrant we're in, which means it kind of matters how I draw the picture and think about it. So the fact that I'm in quadrant 4 means that I draw my triangle in quadrant 4. So what do I mean by that? Well, here's the idea. I'm told I'm in quadrant 4. The angle is going to look like this, okay? So the theta that they're giving me, if you will, is all the way around here. This is theta. It's a weird angle, but this is the angle theta, okay? Here's the terminal side, though, in yellow. I always make my triangle to the x-axis. So this triangle is going to go straight up from here. Okay, don't be tempted to put it over to the y-axis. Never does that. It always goes up to the x-axis. So the triangle gets drawn like this. Okay, we got a right triangle down in quadrant 4. Everybody good? Okay. Now, what we learned in a previous lesson is that cosine is adjacent over hypotenuse. So this angle, I'm going to call it theta prime because it's not the same as theta. This is a coterminal angle with theta. Okay, it creates the same triangle. So the trig values for cosine of theta and cosine of theta prime, right, this coterminal angle are going to be the same. That's what coterminal angles do for us. I just want to make mention of that so you're not thinking, but theta's over there. I know it is, but it doesn't matter, okay? So I'm supposed to be getting adjacent. So which side is adjacent to the theta prime? The one on top, the one that's over here, or the one on the right? On top. Adjacent means that it's touching it, right? It forms part of the angle. So the adjacent, which is the top number, will be a 4 right here. Okay, pretty good with that? 5 is supposed to be the hypotenuse. Hypotenuse is always opposite the right angle. So this is my right angle. My 5 will go here. Okay? So I need to find the third side. How do I find the third side when I have a right triangle? Pythagorean theorem. You got it. So I've got this side. I'll call it A. A is what I usually go with as my general one. So I've got 3 squared plus A squared equals 5 squared. Okay? Oh, did I get a 4 in there? I'm sorry. I wrote 3. Thank you. 4 squared plus A squared equals 5 squared. So 4 squared is 16 and 25. So when I subtract this, I have A squared is equal to 9. So Braden's already telling me I should be getting 3, and he's close to right. Okay, no, it's square root of 9. But I'm going to get what, Isaiah? It's going to be negative 3. Okay, so what we've done so far is we've said, okay, square root of 9 is 3, and we have ignored the fact that there's a plus or a minus when we do this, right? So there really is a plus or minus when we do this. This one is negative 3. Why? Because I'm going down, right? This location right here, it's not marked, but it almost is. This location right here is an ordered pair, and the y value of this ordered pair is negative. So the side that's corresponding to the y coordinate will be a negative value. So this A over here is actually negative 3. And we can do this because we're told that we're in quadrant 4. right? If we weren't in quadrant 4, we wouldn't actually know where to draw the triangle to decide, is it a positive or is it a negative? But we know because we're in quadrant 4. Now that we have this picture, you can think of this picture and do right triangle trigonometry if you would like. Or you can think of this picture and you can think of it as the ordered pair. This ordered pair's x value is 4 and its y value is -3. Okay? Now, we already have cosine given, which means the easy one to find is secant. What is the secant of theta if the cosine's 4/5? 5/4. It's the reciprocal. We could have done that without any of the work below, right? So if you get stuck somewhere, at least write down what it is that you know as an easy thing. Secant of theta. We know that one, okay? The others are a little bit, well, they take a little bit more work anyway, because they actually require my picture. The sine value is supposed to be, you can think of it either as the opposite over the hypotenuse, which is fine, or you can think of it as y/x. So y is 5. I didn't mean y/x, I meant y/r, excuse me. X is 4, and y is -3. Right? So you can think of it as y/r if you wish. So I wrote it wrong. I said it wrong and I wrote it wrong. Well, at least I'm consistent today. R is 5 down there. We'll go with what we can. Okay. So if you want to do opposite over hypotenuse, you're looking at a triangle and you're thinking, okay, it's -3/5. If you want to think of it as y/r, the y value is -3 and the r value is 5. It's still -3/5. So my sine value is -3/5. Its counterpart, its reciprocal, is cosecant. What is the cosecant, then, of my angle? Yeah, it's -5/3. I just flipped the fraction, right? We good? All right. Tangents next. Tangent of theta. Well, tangent of theta, again, picture if you wish, is opposite of hypotenuse. Or the tangent of theta is y/x. So either way, I'm going to get -3, because that's the y and that's the opposite, over 4, because that's the x and that's the adjacent. So this is -3/4. So then, what would my cotangent be? Yeah, -4/3. And notice, everything that I wrote over here, sine, cosecant, tangent, cosecant, they're all negative. They should be, because where am I located? Quadrant 4. And in quadrant 4, all of those are supposed to be negative. So doing a real quick check of your signs, because signs get lost. I mean, let's be real, they do, right? Signs are easy to lose along the way. Doing a real quick check of your signs at the end to make sure you're getting the values you should be is probably a wise thing to do at that point. Okay, any questions on that? All right, let's see what's next. Ooh, a reference angle. I actually used something that was a reference angle. It's also a coterminal angle, but a reference angle in the last problem. So we're going to let theta be a non-acute angle. So non-acute means it could be what? Could be obtuse. Could be right. It could be straight. And it could be really big like this last one, right? Our book did not give this a name. At least I don't think it did. I didn't notice it, but this is called a reflex angle. And so that's definitely bigger. It's not acute. It's definitely bigger than a 90-degree mark. So all of those things are included in this non-acute thing. It's just telling you that the angle measure, it's bigger than 90, right? Bigger than or equal to even 90. So it's non-acute angle. In standard position means that the initial side starts on the positive x-axis, just like we've been doing, right? Initial side's going this direction. Its reference angle is the positive acute angle theta formed with the terminal side of, theta prime, formed with the terminal side of theta and the x-axis. It's the theta prime that I referenced in our last problem. I called it a coterminal angle, and it is a coterminal angle, but it's actually also called a reference angle. And it's the angle that's of best use to us, right? It's the easiest one to have information about and to work with. So it goes back to wherever the closest x-axis is. Maybe the positive x-axis, it may be the negative x-axis. but it goes back to, or down to, or up to, whatever you want to use phrasing-wise, the x-axis. Okay, always going to the x-axis. So how do we find reference angles? Well, to be honest, I'm a very visual person. I see the imagery and I can figure things out. That doesn't work for everybody, but we'll talk about that as we work through if you're like that too. If you're not, here's some details about how you can think about it from a more process-oriented step. You know, instead of looking at a picture and thinking about it, you're thinking about it like a list of, list of do's and don'ts. Like this is the list of do's, okay? So if the angle is less than 360 or 2 pi, we can draw a sketch of the angle in question. That's what we did on the last problem. And then we can find the angle measure back to the nearest x-axis. Okay? That's great if it's less than 360. If it's more than 360 or 2 pi, we're going to find a positive angle theta that is coterminal with the given angle. What does that mean? Well, it means that we're going to have to go with, okay, coterminal. So if it's more than 360, we subtract 360, and we do it again, and we do it again until we have a number that's less than 360. Or if it's in radians, right, like 2 pi's, right, in pi's, we subtract 2 pi, and we do it again and again and again until we have a value that works. Now, the same is true with negative values, right? If it's negative, that's okay. It just meant that it went backwards around the unit circle, right? It didn't go counterclockwise, it went clockwise. And so we would add 360, or we would add 2 pi until we get a number between 0 and 360, or 0 and 2 pi. That's how we found coterminal angles. So we have an extra step involved if we have it in this category number 2. Category number 1 is how we had our first picture drawn just a moment ago. Now, the difference is we didn't actually have an angle measure given. We were just told which quadrant we were in. Now we're going to actually have angle measures given. So here are 3 different angle measures. I'm trying to hit some of the different features along the way. So notice the first one is in that first category. It's less than 360, right? The second one is in the second category. It's more than 360. And the third one is the negative one that I talked about. We've got some degrees on here. We've got some radians on here, and we're going to work with both. Okay, so if something is already less than 360, we can go immediately to a picture. And from our picture, we need to figure out which quadrant we're in. Which quadrant are we in if we have 205 degrees?
3.
Quadrant 3. Everybody good with that? Okay, cool. So here's quadrant 3. Let me draw it in. We're over, wow, that's really thick. Let's try that again. There we go. Roughly speaking, we're over here, right? Okay, well, 205 degrees represents all of this. But what the description was for, this is theta, right? And theta is 205. What the description was for a reference angle is that it should be where I've ended. I'll put a dot on my graph. And I should be going back to the positive, or back to the x-axis, not necessarily positive. In this case, it's negative x-axis. So the reference angle I should be getting creates this triangle. Do you see the triangle? Good. And the angle that I'm talking about then is this theta prime. That blue is not real. Well, it's not too bad on your screen. I think it's still visible anyway. Y'all good with that blue? You writing with that blue for a little bit? Okay. How can I find this piece then? Because that's the angle I'm looking for as my reference angle. What would I have to do from this picture to be able to figure out what that little angle is compared to the entire angle that's 205? Subtraction. What would I subtract? 205 minus 180. So why? Well, because this piece at the top is 180. And that's the piece that I don't want included. So my reference angle would be 205 minus 180. What is 205 minus 180? 25. So this angle measure for theta prime is 25. You should check. Is that an acute value? Yep, it is, because it should be giving us an acute value. If it's not, then you've made a mistake somewhere. Probably got to figure out where it was, right? Yeah, it's an acute angle. Okay, 535. You got to subtract 360 to start. That's the first thing. We got to have a number between 0 and 360 to draw the first picture to begin with. So we're going to subtract 360 from the very get-go. So if I subtract 360, I will find a coterminal angle with this. And what is 535 minus 360? 175. Okay, very good. 175. Which quadrant is 175 degrees in? It's quadrant 2. So this time I'm over here, right? These are not drawn to scale in any way, shape, or form, right? Y'all good with that? We're just giving ourselves an image. So this is 175. But my reference angle is supposed to take that yellow ray, right, and go to the nearest x-axis. Well, the nearest x-axis goes down this time, yeah? So my angle measure, I'm not even going to draw the triangle because we don't need it unless it's helpful to see, in which case, of course, do it, is this orange piece, right? This orange piece right here is theta prime. So how do I find the angle measure my orange piece is?
180 minus 170.
Yeah, it'd be 180 minus 175. And you don't necessarily need to write 180 minus 175 down. I get that. Isaiah was telling me from the get-go, this is 5. He saw it. So if you see it, that's fine. Just, it's 5, you bet. But I wanted to write it down because I wanted you to see that those two formulas are not the same. One was the angle measure minus 180. The other one is 180 minus the angle measure. But the decision on which formula, if you will, that I'm using is based on the picture. I can't just give you, very conveniently anyway, this is how we do it. This is the formula. The picture forces us to do certain things that we need to do. Now on the last one, 13 pi over 6, you could change this into degrees if you wish. I'm not going to because I want you to see how to work with it in radians. What is the first thing that I would need to do with this one?
Add 200 to 80
Yeah, how come, Carson?
because it's over 360. So 2 pi is 360, so it's bigger than 2 pi because it's, yeah.
Yeah, okay. So there's two things going on, and you've mentioned one of them. 13 over 6 is bigger than 2. Is everybody good with that? There's something else going on that's going to cause me to have to add to this one. Do you see what it is? It's a negative. So there's two reasons here that I need to add 2 pi or subtract 2 pi. I'm going to have to manipulate with 2 pi. One of them is because it's negative, and the other one is because the value is bigger than 2 pi, okay, in terms of a negative value. So we're going to start with adding 2 pi. Okay, so this is negative 13 pi over 6 plus 12 pi over 6, which gives me what? Negative pi over 6. Okay, are you good?
Yeah.
Now, if you want to add another 2 pi to this, you could. It wouldn't hurt anything. But this value can also be thought of and done in a negative way. I don't mean negative as in bad. I mean negative as in direction, right? My angle is supposed to go up counterclockwise if it's positive. But if it's negative, it's going to go down, right? And it's actually easier to not change this into a positive and to think of it as it's going down. This angle going in this direction is negative pi over 6. That's what it is, okay? But my reference angle is supposed to be the positive value of that. So if I go down to get pi over 6, what is that angle measure in a positive sense? It's just positive pi over 6, right? So in this case, it almost looks like, well, you just took the absolute value or something like that. Or you just removed the negative. But again, it's the picture that's forcing the issue, right? It's where it is in space that's telling us what we do. Okay? So that's all well and good, but why does it matter? Well, it matters because we're going to take trig values of these kinds of angles. Okay? So we're going to have these kinds of angles that are either too big or too small, right? Too big, positive, or negative. And we'd like to figure out where in space we are when we have something like 405 degrees or 23 pi over 4. Both of those values, one's radians, one's degrees, are too big Agreed? They're too big. So what would I do to change 405? Well, I'm going to use reference angles first, and it's bigger than 360, so what's the first thing to do? Subtract 360. So I'm going to take the 405, and I'm going to subtract the 360. What's 405 minus 360? 45 degrees. Now that's a lovely, is it 45? Somebody said 45, is that right? Okay. I've got funny faces going on too, so I want to make sure I'm good. Sometimes I just take what you give me. I don't even look at my notes. You may not give me the right thing, so we're good. 45. 45 is a great number. It's one of our special angles that we talked about, so it's actually a very friendly value. What quadrant is it in? It's quadrant 1. So it's over here, like so. So this piece right here now, that's a terrible color. We don't want to do that. Let's use white, is 45 degrees. But we're supposed to be finding the tangent value, not just the angle measure, right? I'm not going to leave this as tangent of 45. I want to find the value at tangent 45. But as I mentioned, this is actually one where wanted to just make it longer. There we go. Where we found a triangle that matched this before. This is one of our special angles. We'll talk about what happens when they're not the special angles later, but this one is. Do you remember the side lengths of the special triangle that have 45s in them? 1, 1, and square root of 2. This is the special triangle, 1, 1, square root of 2. So using that triangle and the fact that we're finding tangent is opposite over adjacent. What is the tangent of, I'll put 45 in because I actually have it. What is the tangent value of 45 degrees? You're thinking about it from a different perspective. You're right. But from the picture that I've got here, what did you say, Anna? It's 1. So it's 1 over 1, or it's just 1. You're thinking of it as square root of 2 over square root of 2? Something like that? That's okay. That's another way to do it. From we're going to get to the unit circle in 1.4, and we'll think about it that way too. Okay. But is everybody good with this picture and how I get the number 1? The opposite side and the adjacent side, they're both equal. So whatever they are, it's going to give me the value 1 when I divide them. Okay, 23 pi over 4. Okay, somebody tell me, what is 23 over 4? More than 2. It's a really good answer, actually. It's more than 2. Probably like 5 something. Yeah, it probably is. So let's actually subtract my 2 pi each time and figure out what we have. So if I have, I'll write it down here in a couple of steps, 23 pi over 4, and I subtract 2 pi. 2 pi is the same thing as what in terms of over 4s? 8 over 4. So 23 minus 8, 4, not 3. 23 minus 8 is what? 15. What can you tell me about 15 over 4? Still bigger than 2. So what do we have to do? You keep going. You just do it again, right? So we're going to take the 15 pi over 4 now. We're going to subtract 2 pi, but we already established that that's the same thing as 8 pi over 4. So that's 7 pi over 4. 7 pi over 4 is actually less than 2 pi this time, right? 7/4 is smaller than 8/4. So we got to figure out where we are in space. Okay. So Braden's up here telling me we're in quadrant 4. 7 pi over 4. That is in quadrant 4. So if you think about remembering, like this is the way it goes. This one's, try to zoom in on my screen by touching the screen. That's not going to work. This one is pi over 2, excuse me. This one is pi. This one is 3 pi over 2. So 3 over 2 is 1/2. 7 over 4 is 1.75. We are in quadrant 4, either thinking it in decimals, turning it into degrees, whatever it takes to get you to the right quadrant. For now, just do that. It's okay. We're in quadrant 4. All the way around here is 7 pi over 4. So then, what is this angle here? If all the way around is 7 pi over 4, what is this missing white angle? It's what?
1 over 4?
Yeah, it's pi over 4, right? Yeah, it's pi over 4. So a couple of ways you can think about that. We said that 8 pi over 4 is equal to 2 pi, right? And which is true. Well, if 8 pi over 4 is equal to 2 pi, it means going all the way around to here should be 8 pi over 4. And if I'm already at 7 pi over 4 at my yellow ray, one more pi over 4 will get me all the way to 8 pi over 4. So you can think about it visually. Second option, we could have taken one step beyond over here, and we could have gone and subtracted 8 pi over 4. And if we did, what would we get? Close. Negative, actually. But yeah, pi over 4. Negative pi over 4. What does that mean? Well, it means I'm going pi over 4, but I'm going clockwise, which puts me still right here. This is at pi over 4. So the triangle that I'm going to get then, coming back up here, I've got a messy triangle here, but the triangle is nonetheless. This angle pi over 4, it's the same thing as up there. It's a 45-degree angle. 45 degrees and pi over 4 are the same quantity. I've got a 45, 45, 90 triangle. We're going to get to the unit circle. We're going to get there soon. Okay? So we've got this angle down here. We're at pi over 4 in the lower quadrant here in quadrant 4. And which one are we supposed to be finding? Cosine. Whoa, whoa, whoa. The cosine now of pi over 4, right? But it's negative, but it's pi over 4 down here, right? Cosine in this triangle, this is 1 square root of 2, almost. This is actually negative 1 because it's the y value. So I need to know the cosine. Cosine is adjacent over hypotenuse. Adjacent is this 1 at the top because the angle always forms in the middle, the central angle. It's this 1 at the top over the hypotenuse, which is square root of 2. So this is 1 over square root of 2. Yep. And if we rationalize that, we will get that this is the square root of 2 over 2. All right, that ends this one.